What I want to talk about today really is the advent of how well the open source community is really pushing forward, and how much Databricks is right behind that goal and making sure that all of you and all of the customers that we have can make the most of open tools to use your data to the greatest extent. So a couple of weeks ago, we launched a new large language model, DRBX, which at the time of release, that may have changed about 2 hours later, was the state-of-the-art open LLM available to the public. Now, just in the essence of time, we might not cover all of these pieces, and feel free to ask questions if you do have them. But I want to talk a little bit about what DRBX is, why we built it, what it's made of, and really how it compares and what this means for the community at large moving forward. And of course, you'll have a chance to try DRBX. You can try that right now even, and I'll show you how you can do that as well. So like most open models, we released two versions. A base model, which really can give you some tasks, things like few-shot learning that we saw when models like GPT-3 were released. We saw these so-called emergent properties where they can pick up and extrapolate to tasks that they weren't specifically trained on. But the idea of the base model is really to allow you to have a good starting point to train further on your data, to fine-tune it, to improve it and align it with how you want your models to work. And then, of course, if you don't want that, if you just really want a good instruction following model to include in things like your LangChain pieces or your RAG architectures or whatever it happens to be, we also have the DRBX instruct model as well, which has both of these models were built end-to-end entirely on the Databricks platform. I think we're pretty much the only company that can say something like that. So from both creating the data, working with the data, making it and getting it into a good state, training the model, fine-tuning the model, optimizing it, deploying it, serving it, all of that is done in end-to-end in the Databricks platform. So we're very happy to see that. One of the nice sort of party tricks that DRBX has over models like Llama 2 is really its speed in processing tokens. We have a pretty cool architecture for DRBX, which I'll talk about in just a moment. And what that affords us is a much faster inference speed, even for a model that surpasses the abilities of Llama and other models. If we take a look at some pretty graphs, we can see the DRBX models against some of the fairly common other open models like Mixtral, Grok, and Llama 2. Obviously, Llama 3 is going to be coming out in a couple of weeks or so, most likely. So this will change again, but that is the sort of story for the LLM wave that we're currently riding. And so DRBX, you can see, really shines in most of these, or in all of these evaluations. Now, I will say, show me your evaluation, I'll show you the LLM that has been trained to do well on it. So you do also have to take these with a little bit of salt. And what we found is really combining these different evaluation suites and taking an aggregate is really a better way of figuring out what's going on. Because we're dealing with language models, it's very hard to test them. It's like going through school and having an English teacher that likes you or doesn't like you, it's going to affect your grade. Whether or not you have mathematical skills and you can get the exact answer or not, with language, it's much more difficult to really evaluate it. And so all of these plots can be misleading is perhaps a strong word, but we really have to take it in the sort of holistic viewpoint and see what works for you and how well it performs on your tasks. That's really the best way to look at it. We could talk about some of the different evaluation suites, but I really want to sort of push forward and see how this compares to the original ChatGPT. So that took the world by storm, was the most adopted, was the most quickly adopted technology in human history, and we've now got an open source or an open model that goes toe-to-toe and surpasses the original ChatGPT just pretty much 18 months later. And I think that's really remarkable and shows how much the entire community has taken the open source philosophy and shown how much they can achieve given really not a lot of time at all, if you really think about how long it's been since ChatGPT was released and how quickly the team at Databricks was able to build something to surpass it. So I think that's really impressive. Looking at this problem of evaluation, we also have an open source evaluation suite called the Gauntlet. And what that does is it gives a nice sort of holistic picture of how these different models perform on a variety of different benchmarks. So it's kind of like an IQ test for these models. And while it's obviously very nice that our brand shiny and new DRBX model is the most performant here, I think the thing that I find most hopeful to see here is just as we've progressed in time, we're really pushing out the boundaries in all of these directions. We're really getting some great results. To see the outermost circle here is at 90%, and we're really marching towards that at a really steady pace. And I think that's commendable for both the open and closed source communities that we've been able to do that in a really short amount of time. The way that we do that is by innovating on the data, but also on the architecture. Now, everything that I'm going to talk about right now, you can also find in the public blog articles as well. So if you want some extra reading, you can always Google DRBX blogs and you can find all of this information. But DRBX is a decoder-based LLM, just like most of the LLMs that you're familiar with. It was trained entirely on publicly available data. We didn't use any customer data for this. We did train it on 12 trillion tokens with a T, which, yes, is a lot and is pretty much the highest that we've seen for a base high-performing LLM. I think what we'll see as a trend as we continue is not necessarily a march in parameter count. That sort of has reached a bit of a steady state, but I think we'll see the tokens and the training data really take over as the most important differentiator between the success of different models. We also leverage something called curriculum learning, which essentially boils down to making the task of predicting the next word more difficult as the model gets trained further and further. And so that really highlights that it's the quality of the data over the quantity of the data, but if you can get quantity too, then you really have things set. Training took just about 3 months on a handful of GPUs, I would say, but still in the scope of what it took to build, say, the first ChatGPT and things like that. Again, this is really showing some impressive progress. This model we refer to as a fine-grained, sparse mixture of experts. So mixture of experts, for those of you unfamiliar, a large language model, a sort of vanilla large language model, is effectively built out of a series of Lego blocks. Each of those blocks has 2 pieces in it. They have something called an attention section and a feed-forward neural network section as well. In the mixture of experts flavors of LLMs, the only difference really is that the second part of those Lego blocks, the neural network, is chopped up. And then there's a little switching mechanism that changes where the signal gets sent to. The benefit of doing that is you allow the network to specialize for different areas. One part of that neural network might learn more about history. The other part might learn more about science. With deep learning, you don't really get to control exactly what it learns, but illustratively, you can think of it like that. And so that means that at inference time, you actually only need to activate a much smaller amount of parameters. And so while the model itself has 132 billion parameters in total, every time you send a single activation, a message through the network, you're actually only using 36 billion parameters. And so this gives you a nice balance of intelligence and effort for answering or responding to different inputs. There's obviously more details available for this in the blog articles and in more information to come. But this is really the source, the secret sauce behind the success of this model. Now, I won't go into too many other details. There's a lot of technical aspects of this. This being a technical talk, we do want to cover some of them, but also just in the essence of time, we won't go too deeply. And then just finally, before I wrap, the way that we built DRBX was really to utilize the open source community and the libraries that, in particular, our Mosaic team has built out. So in particular, the Composer library, the Streaming Datasets library, which makes sure that your GPUs are constantly fed with data the LLM Foundry, which is where we define all of the different architectures, and then the all-important evaluation gauntlet, where we make sure that the models can behave in the way that we want, and that we can compare sort of equally across different models as well. Now, before I wrap up here, I do just want to also give a shout out so that you can play with DRBX yourselves. You can head over to Hugging Face and play with it right now, and you can chat with it there as well. So with that, I'll wrap and let you guys build whatever you can on DRBX. So thank you.